So now we're going to continue our exploration of stage one of the UbD template where we're identifying desired results, and we're really going to dive into understanding goals and how to write them. So this part of the template is that middle section right below the transfer goals, and it's in the that meaning and then parentheses understanding heading, where we're really asking ourselves what specifically do we want students to understand, and really what inferences and generalizations should they make. So this portion involves two different parts: these understanding goals, which are the actual generalizations or inferences we want students to make during the course of the unit, and they always start with this sentence starter. Students will understand that. That word "that" is really important because it forces the unit designer to actually write a sentence about that specific inference or generalization that they want kids to make. And then this chunk also encompasses essential questions, these open-ended, thought-provoking questions that kids will keep considering, that really drive the inquiry of the unit and help students reach understanding. So overall, understandings are the specific insights, inferences, or conclusions about the big idea that we want students to leave with, and essential questions frame ongoing and important inquiries about that big idea. So they go together because those essential questions help kids continually consider those big ideas of the unit that will hopefully help them understand even more. So overall, let's go over some characteristics of good understanding goals and good essential questions. So good understanding goals, as you can see here in teal, are full sentence statements reflecting conclusions about the big ideas. That connects back to what I had said before, that if you say students will understand that, then it'll be that full sentence statement of what you want kids to understand. These understandings are gained only through guided inference, not taught facts. If you teach an understanding goal directly, then it ends up just being knowledge, not actual understanding. So students have to be able to be given opportunities to make these inferences kind of on their own, but through your coaching and the learning activities that you and your team provide to students so that it guides them to make those inferences. Finally, good understanding goals are often abstract, not obvious, and misunderstood by students. And you'll see we have a science example coming in hot that I would say is a pretty good example of a misconception that students might have that can be turned into an understanding. Now, good essential questions should be explored, argued, revisited, and reflected on. So they don't just have one right answer. They have various plausible answers, hence why we can continue to explore them and debate them and keep revisiting them to continue to grow our understanding over the course of the unit. Good essential questions should provoke deep thinking and inquiry. So we want to intentionally write these questions so they go beyond that surface level and really drive that inquiry throughout the whole unit. And then finally, good essential questions reflect genuine questions people really ask. I think that connects to that idea of transfer, which we talked about previously. We want our transfer goals to matter to students when they beyond our classroom. And so if we're asking these essential questions that people legitimately ask, then that connects to that real world application and consideration that drives the inquiry of the unit forward. So let's look at a few examples. The very first set is from a science unit, and we want students to understand that most of what goes on in the universe involves some form of energy being transferred into another. That's a pretty big idea, a pretty big conclusion or generalization about this big idea of energy being transferred. Um, Also, transformation of energy usually produces some energy in the form of heat, which spreads around radiation and conduction into cooler places. I thought this one was a pretty cool example of a misunderstanding or a misconception that students might have about science. So sometimes we refer to things getting colder or getting hotter, but really when something gets colder, it's because the heat is spreading. The heat from one thing is spreading to its surroundings or to something else near it, which is why it gets colder. It's not actively getting colder and colder and colder. It's because the heat energy is leaving it. So that might be an example of an understanding that addresses a misconception that students might have. Now let's dive into these essential questions. For this same unit, we have, can we ever know for sure what shapes our climate? I feel like that's a pretty realistic question that people ask. Things change all the time. Technology has changed so much over this century. And so we have to constantly ask ourselves, can we really ever know for sure what what shapes our climate, because it could be so many things. That question could also potentially be debated or revisited and reflected on over the course of the unit. How about this one? How effectively can we predict weather events in any given place? I feel like that's a question that meteorologists constantly ask themselves, and like anybody who watches the weather who might not trust a meteorologist. But it's something that we could continue diving into over the course of the unit and could provoke that inquiry over that unit. Here's another unit. It's a health unit. We have students will understand that a balanced diet contributes to physical and mental health, and dietary requirements vary for individuals based on age, activity level, weight, and overall health. So those are pretty good full sentence statements reflecting conclusions about the big ideas. Somebody might have a misconception and think that a balanced diet only contributes to physical health but not mental health. So this first understanding goal might address that misconception. And also another misconception could be the same dietary requirement should apply to everybody, but through guided inference, through experience, looking at the dietary requirements for different people in their own contexts, a student might come to this conclusion, infer that dietary requirements vary for different people based upon their circumstances. Now let's check out these essential questions. We have, what is healthy eating? How can healthy eating for one person be unhealthy for another? And how do modern eating habits contribute to health problems? Those definitely could promote the inquiry over the course of the entire unit. In terms of what is healthy eating, people devote their whole lives to investigating different models of healthy eating to figure out what works best for them. This idea of how can healthy eating for one person be unhealthy for another really guides our inquiry and helps students draw the conclusion that dietary requirements vary for people based upon their individual contexts. And also this, how do modern eating habits contribute to health problems? I mean, that could have various plausible answers that could be continually revisited over the course of the unit, and people might really genuinely be asking that question. Now for math, we have some understanding goals. Students will understand that mathematics can efficiently describe naturally occurring patterns. And students will also understand that linear equations and their graphs are concise methods for representing relationships that involve constant rates of change. So this first one, mathematics can efficiently describe naturally occurring patterns. That's a pretty big idea, and it's a full sentence statement that describes that can be applied in different contexts and situations. It's also something that students can infer over the course of the unit as they investigate different sets of data. They can figure out over time that math can officially describe these patterns that they find in different data sets. Here are our essential questions. What is the best way to represent a particular relationship? That's something that can be explored, argued for sure, debated, revisited, reflected on. It could have various plausible answers depending upon the context. Like what's the best way in one situation might be different in another situation. And it's a question that people legitimately ask if they're trying to find the best way to represent a linear relationship. Our second question is this: what are defining characteristics of a type of relationship? How do we best measure and interpret them? And I can definitely see that question really promoting deep thinking and inquiry over the course of the unit as students look at different types of relationships in mathematics and try to figure out how to best measure and interpret them. Finally, here's a world language unit. Our understanding goals are this: students will understand that the culture of Spanish cities is heavily influenced by the Spanish Plaza, and certain forms of language are more appropriate for a commercial setting. When I think about the second goal in particular, it's a conclusion about a pretty big idea that would impact students' use of language, like basically for all time. And that it's something that students might be able to infer when they explore different forms of language that are specific to different commercial settings. They may be able to draw that conclusion. Our essential questions are these: how important is it for a Spanish city to have a plaza? If students continue to revisit this question throughout the course of the unit, it will help them realize this understanding goal that the culture of Spanish cities is heavily influenced by the Spanish Plaza, and they'll have all sorts of ways to back up why the plaza impacts Spanish city culture so much. And then finally, how does our choice of words affect our ability to be understood? That is something that people genuinely ask themselves anytime they are choosing their language when communicating with other people. And so it might also help students recognize that the choice of words in a commercial setting might have to be different than in other settings. So let's dive into understanding goals first. And let's maybe practice. You can feel free to pause the video and practice turning these goals that might not necessarily be understanding goals into actual understanding goals. On the left-hand side, we have the characteristics of good understanding goals. And don't forget, starting the sentence with students will understand that, and then finishing the sentence will really help you create a sentence that reflects a conclusion about a big idea. So go ahead and pause the video, and then I'll show you what I had come up with. All right, so hopefully you've written some amazing understanding goals based upon these three ones that we have here. Our very first one, here's mine. Our very first one is this. Students will understand how to find a pattern in a set of data. That's not really a full sentence statement about a conclusion, about a big idea. It's more of just like a skill. They'll know how to find a pattern. So I phrased it like this. Students will understand that data analysis can surface patterns that help generate valid predictions. So that's something that they could conclude over the course of the unit. And it's something that they wouldn't necessarily be explicitly taught. It would be like surfaced through guided inference over the course of a unit. For the second goal in orange, we have students will understand the food pyramid. That's really vague. What do we want them to understand about the food pyramid? Not sure from that goal. So here's what I wrote. Students will understand that following food pyramid guidelines varies from person to person based upon their unique nutritional needs. Finally, the third one is this in purple. Students will understand inheritance of genetic traits. Again, that's really, really general. We don't really know specifically what we want students to understand from this sentence. So here's how I rephrased it. Students will understand that the inheritance of genetic traits changes over time as globalization continues to occur. So that's a conclusion about a big idea. And it's something that could be taught through guided inference and not necessarily taught facts. And this next slide, I'm now going to show you some examples of some essential questions that we can revise as well. So feel free to pause the video. We've got 3 essential questions that might not really fit our good essential questions checklist. Feel free to use that checklist and re-envision those essential questions. And then when you're unpause when you're done, and then I'll show you my answers. All right. So hopefully you took some time to re-envision those essential questions. Here's what I did. You might have done something different that is equally as awesome. So our first question in blue is, what is the difference between fiction and truth? And that's something that like somebody could just say, well, fiction is something that is created by a person that is not necessarily true, and then truth is real. And so that it might not really have plausible answers necessarily, various plausible answers. So I rephrased it like this. How do fiction and truth connect? So as an ELA teacher, students might be reading works of fiction, but they have they're influenced by true situations that are happening, or might help students come up with universal truths about humanity. So asking this question involves some various plausible answers, could provoke deep thinking and inquiry. Our second question in orange is, what are the components of a plant cell? And that's something you could just like name off the parts of a plant cell. Here's a question that I wrote instead. How do plants survive? And so if this is couched within a unit specifically about plant cells, it helps students kind of think about how does each part of the plant cell contribute to the survival of the plant. So it would have various plausible answers. The relationships of these different plant cell parts could contribute to plant survival. Kids can continue to explore it, and it could promote inquiry throughout the course of the unit. Finally, the third question in purple is this. How do we estimate to the nearest whole number? Well, we've all kind of heard like if it's 0.5 or above, round up, and less than 0.5, round down, but in some real world circumstances, that really does not work. So that rule doesn't always apply. So we want to ask maybe a question like this. How do we estimate accurately? So kids might have to be in a situation where maybe they have to estimate how many pizzas might I need to feed a certain group of people? Well, in that instance, you would always want to round up. But maybe in another instance, and it's not real world, it's okay if you round down. So that question would help kids continually think about that. Hopefully this video was helpful for you to consider essential questions and understanding goals. If you're in a good place, feel free to jump right into your unit template and noodle around with your own meaning goals.